Hello. Uh, so thank you for watching this video. So this is for sample problems from 171 to 180. Okay. So problem 171. It says we want to find the variance for this x. We want to calculate the variance. So here the two variable distribution. So find this Vx. So we can have two ways. We can regard it as a 2D or 1D, right? We can regard it as a 2D or 1D. So 1D means like we just focus on the marginal distribution for x. Okay. So for 2D, we just let us say what is the variance of x. We just use the formula Vx equal ex squared so minus z square of x. So to calculate the x square of x, we just use this. Okay, so this is just a double integration, right? So x f x y dx dy and x square. So x square is just this double integration. So x square f x y dx dy. So here we just use just regard it as this as a 2D a double integration problem. So here this density function fx is constant, is half. So and this d. So here we need to find this region D is so what is this? X absolute value plus y absolute value between 1 and 0. So this problem. So we just check this. If x y both of them are positive, so this become x plus y equal 1 and x plus y equal 0. So this is this part, right? Okay, so we know when x in this second quadrant, so we know this is just like this. Okay, so this d is such a square. So here's 1 0, here's 0 1. Okay. Okay, so now let's check this is x. So x. So x. Okay, so we can find x equals 0, right? Symmetric x equals 0. Okay, because here x is positive, here negative, so just cancelled. So for x squared, we can say equal 2 of the positive part, right? So x squared, the positive part. So for this x, we just check a positive part. So for positive part, we also have the two parts. So for the two parts, x is same. So we can say this equal another 2, right? Equal. So we just say this part d1, just the fourth quadrant part. So d1 x squared dx dy. So now this integration is easy, right? So x squared dx dy in d1, we say in d1 this is d1, right? So x x squared for x from 0 to 1. So once we determine x, y from 0 to this y. So this 0 to this line is x plus y equal 1. So for fixed x, y equal 1 minus x dy. Oh, I'm sorry, here multiply half. Yeah. So if density functions half, I forget this half. So this actually is multiply half. Yeah. So this one, so very easy, right? So that's equal 0, 1 x squared, 1 minus x dx. And this integration is x squared minus x3. So x squared minus x3. So x squared minus x3 dx. So from 0, 1. So this is just the 1 over 3 minus 1 over 4. Okay, so the answer is this multiply, I think multiply 2, right? So for this problem, we want to find the probability, the total benefit paid. Total pay is 40A or less. So we want to find this probability. Total pay is less than or equal 40A. Okay. Okay, so then we want to check what is the payment, what is the benefit. So here we have these three cases. If there's no claim, the benefit, the payment is 0, right? So this equal this case actually 0.7. So no claim, and one claim. So one claim, such a probability is 0.2. So this is the case. So we want to check for this case. So the claim amount a uniform distributed. So we say this is x less than 40A. So this x for uniformly from 0 to 60. Okay. And okay. And also 0.1% having two claims. Okay, so two claims, first claims we just say x1, second claims x2, so that together addition less than 40A, right? So for x1, x2, xi also follow this uniform distribution. Okay, so for this probability, this is easy, and this one is easy, right? So this is just equal 40A over 60. So only thing is this probability. So let's change this as x plus y. Okay. So this is what is x, what is y, x, y follow uniform distribution with from 0 to 60. So we can see like x and y. So x is uniform from 0 to 6. Y also 0 to 6. So x, y just 0 to 60. So here 60, here 60, right? Okay. Okay, so x, y less than 40A. So this line 40A. So here's 40A. So we know this is 40A. Okay, so we just find this probability. X plus y less than 40 is this part. So this one, so we say equal, so we say this is totally is 60 times 60. Okay, so what is this area for this triangle? So this equal half 40a square, right? So then after some calculation, we can find the answer. Yeah. Okay. So for this problem, we want to find find fusing 4 tornadoes occur in a 3-week period. So the condition is the number of tornado in 1 week. So here, so be careful here, in 1 week. So this in follow Poisson distribution. With the mean is 2. So this is just lambda equal 2. Yeah. Okay, so now we consider 3-week period. So this in, so let's say I just put this as n. This 3-week. So this mean should be 6, right? Okay. So 1 week average is 2. Then 3 weeks average 6. So we just want to find this. What is the probability that in 3-week period this is less fusing 4? So less than 4. So which is like m, so it can be 0, 1, 2, 3, right? So we just need to find this. So here this parameter lambda equal 6. So this probability just equals this, like so. We use this formula equal k. This probability so here's k factorial lambda k is negative lambda, right? This formula. So here we just put the lambda equals 6. So this equal is negative 6. So k equals 0, 1, right? K equal 0, 0. K equal 1, just lambda is 6. Okay, just and x equal 2, lambda 6 square over 2, and 3 over 3 factorial. Okay. So then just use the calculate, do the calculation. Okay, so here we want to find the probability that the system will overheat. So what is overheat meanings? What is overheat? So overheat, the system will overheat if and only if at least 2 components fail. So totally we have 3 components. So just among 3, like among 3, at least 2 fail. At least 2. So this at least 2 failed can have 2 or 3, right? So such a problem just like a binomial distribution. So we say this probability is if we have two field. So how many such ways? So from 3 choose 2 of 3 choose 2. The field happen twice. 0, 0, 5 happen twice, and the other one is not fair, not overhead, not fair. Then plus 3, all of them, so just 3 choose 3, and but the 3 choose 3, then this thing all are fail. So 3 choose 3 just 1. Okay. Okay, so for this one, we want to determine the probabilities that come the profit. So we just put the profit as x. X is at the most, so we want to find this probability. This profit is at the most is less than 60, at the most 60, right? Giving that the profit is positive, so x larger than 0. We want to find this probability. So x is profit, company's profit. So what is the distribution for x? Okay, so this is x for a normal distribution with mean is 100 and variance is 400. So for standard deviation is thus, right? So there's 20. So these things follow such a normal distribution. Mean is 100, standard deviation 20. Okay, so this probability so become like this, right? So px larger than 0 and x between 60 and 0. Okay, so what is this probability? So we need to change to standard normal. So let's say so px larger than 0 equal p, so z larger than, so 0 minus mu, mean is 100, standard deviation is 20. So this equal z larger than -5. So larger than -5. Okay. So here -5. So larger than -5 is just equal less than +5, right? So this just equal f5. Okay. Okay. So we find this probability should be right. So between 0 to 60, 0 is 5, and 60 between 60 is 2. So answer is thus. Okay. So this probability is calculated, this probability giving that, so this is a conditional probability. Okay, so we just focus on those things. Among the probability that the policyholder has cholesterol here, then what is probably that? So we just check this. So here we say 20% have a high blood pressure, and 30 has this. Okay, so here we have two factors: blood pressure, high blood pressure, and this. So we use Venn diagram. Let's say so we just put here the high blood pressure, and here the high cholesterol, and outside. Okay, so we put those informations. Okay, so says HB is 30%. No, HB is 20, and HC is 30. Okay, so let's check this. With HB among this, 25% have this. So this means this count for 25% of total. So this is the total is 20. So here we say there's 5%, and this is 15%. Totally 20. Okay. Okay. So this is 30%. Then we know this is 25%. Okay. Okay. So now we can find the probability. Okay. So let's see. I'm sorry. Okay. So here condition is among those, right? Giving that the policy has high. So among the 30, so here denominator 30. Among the 30, how many has high blood? So 5, right? Okay. So here calculate the probabilities at the exact one. So here we probability that we just split all into parts. So totally we have 25. So 25. So among the 25, 20 are low, and then 5 high. Right? We split it into 2 parts. Okay, so from here pick 2. We just pick 2. Random select. So then we find that the probability easy. So we find that probably exactly one of them is low. So this means from here pick 1. Exactly 1. So from here pick 1. From here pick 1. Okay. So such a probability problem is really easy. So here randomly we just pick 2. So here from 20 pick 1, from low pick 1, from high pick 1. Okay. So for this problem, we want to find the variance for this. So we just use the definition. Variance for this equal e this square. So this thing is square minus e square of this. Right? So let's check this. So is this. So we need to find is this x over 1 minus x. We need to find this, or this square. Okay. So to find this, just according to the definition, just do some calculation, right? So let's say for this one, so this one just equal x1 minus x. So if x dx and x changing from 0 to 1, so just do those calculation. Yeah, so for this one is equal this square. So fx dx, so 0 to 1. Okay. So for those integration, so say from 0 to 1, so those integrations we should do really quickly. So let's say for this one, so let's say x1 minus x. So what is the fx? Fx is 60, and so here x3 1 minus x squared dx. Okay. So for this one, we say this one is okay. So this equals 60 times 0, 1. So cancel 1 minus x. So this become x4 multiply 1 minus x, right? dx. So this one equals 60. So x4 minus x5. So x4 integrated out is 1 over 5. x5 1 over 6. So for this part, the same way, right? So we can easily find the variance. Yeah. Okay. So for this probability, we want to find this policyholder has at least one emergency room visit, has this, and at least this. Okay, so here we want to find like those probability, like A and B, right? Let's say room visit and stay. We want to find this. Okay, so then we have two factors like room. What is the probability for room stay or room visit? So just say 70% have no room visit. So have room visit is 0.3, right? And no hospital stays or for stay is 0.15, right? And so this is having neither of them. So for this one, we use Venn diagram. So let's see. So here R. So this stands for room. So this is 30%, and for this is stay. This is 15%. Okay. And outside is neither this or that. So this is we put 61%, right? Yes, 61%. Okay, so this part meaning, so this is 39. Yeah, 39, right? Okay. So we know this equals 39 is actually, so we have this like PROS equals 39. So PROS equal PR. PR is so equal PR plus PS minus, right? R and S. So we can find this equals 39 equals this is 30 and this is 15. Okay, so this one we don't know, so we can find this. Okay, so for this problem, we just want to find we just want to find the cumulative distribution function f. Okay, so here we say this loss is for a uniform distribution, so we put this as x for 0 to 5, right? But for payment or reimbursement, y, so y is just let's say from 0 to 5 this loss, so they will pay at most 4. So we can say this y is just is minimum of x and 4. Okay, so between 0 to x, just they will pay x. Then between 4 to 5, they just pay 4. Okay, so we want to find this cumulative function is payment y less than x. Okay, so we say for this one we can have this x, if x is less than 4 or less than 4, we also can put it like a less than 4, less than 0, less than 4, maybe put it less than 0, so 0. If x larger than 0, less than 4, they will pay x, right? Okay, yeah, and oh, they will pay x. Oh, no, they will pay x. Yeah, so this probability is, let's say if here x, the probability they will pay x, pay less than x is over 5, right? And so x, so larger than 4, the probability x larger, y less than, so when x larger than 4, the payment will be, so when x larger than 4, this y less than 4 is become 1. Okay, so this is just this cumulative function, right? Okay, so we can stop. We can stop here. Yeah. So this is the problem from 171 to 180.